Well, our speaker today is Timothy Williamson. He occupies the, what is it, Wickham
Yes.
Professor of Logic
Yes.
and what, metaphysics or?
Logic.
Logic, period. Okay, Wickham Professor of Logic. So he can, and this is a chair in England with a very distinguished pedigree, and it also maybe qualifies the speaker who has written a lot about the nature of logic to present his view about this today. So your title is what, abductive?
No.
No, it changed. I think it's something like internalizing a logical theory.
Internalizing logical theory. Okay, that's good. Okay. Yeah.
Okay. Yeah. Thanks, Tim, for doing this.
Tim, yes. And so we have known each other from, I don't know when, right?
Some years now.
Yeah, some years, right? Yeah.
I think about 30, in fact.
30, wow.
Oh, I did not know you from 30 years ago.
Oh, yes, I mean, no.
Okay.
But I think I first met Saul.
When I gave the John Locke lectures, you were a first-year undergraduate, you say, right?
Yes, well, I didn't meet you then, but I think I did meet you in Oxford in maybe sometime early 90s, something like that.
90s, yeah.
Okay, even Dobby came here to listen to you. So, okay.
This is a dog.
Yes.
Okay.
Well, if I hear growling, I will.
Internalizing logic. Okay, good title. Okay.
Okay, you can start, Tim, whenever you want.
Okay, so I'll start by sharing the screen. Oh, here we are. Now let's make sure that this is working. Oh God, now we've got to do something. Oh, sorry, I don't seem to have control over the screen. I mean, it's not shifting.
Oh.
So
Do you know Yale?
I think I'll let's try if this works. Okay. Yeah, that works. Okay, fine. Well, anyway, thanks very much for inviting me. And I'm sorry that with all that's been going on in Oxford, I haven't been able to come to the other sessions, so that I may be missing all sorts of relevant points that have been made before. So this is going to be a fairly informal talk about how I see the kind of phenomena that we're interested in. I take it, and as it were, just to give you the sense of the what I take the overall picture to be roughly, and so where I'm coming from is anti-exceptionalism about logic. So that's roughly speaking the attitude that logic is not radically different from other fields of inquiry, such as physics. I mean, of course, this is not a very precise view, but this is as it were the general attitude that I'm working from. And so one aspect of that is that if, for example, there are theories in physics, as surely there are, then there are theories in logic. And what one would expect is that if one can adopt theories in physics, then one can adopt theories in logic. I wouldn't expect there to be a difference in that respect between the two areas. But in this talk, I'm not going to be using the A word much at all, because I don't want to get into issues of clarification about whether I'm using it in exactly the same sense as Saul has been using it, and so on. So I'm going to use another term. I'll speak of internalizing theories, not of adopting them. So it's probably better not to think of theories as children. But it's not that I'm using internalize just to be a synonym of adopt, because obviously that wouldn't gain anything. But I will give you some sense of what I'm taking internalizing a theory to be, and I'll develop my account of this, and then maybe Saul can say whether he thinks there's a big disagreement between us on these matters or not. But that's not what I'm going to be pursuing, as it were. I'm not. It's not that I'm out to disagree with Saul. I'll leave him to say how his position relates to what I've been saying. Although I think they're, in some sense, they're concerned with the same general territory. So if we just take the simple case of physics, then one of the first things that we'd want to do is to make a distinction between naive physics and scientific physics. So roughly speaking, we would take naive physics to be pre-reflective ways of thinking on physical matters, and these are instinctive, and they may very well be innate and universal amongst human beings. Whereas scientific physics would be something more like reflective ways of thinking on physical matters, which are learnt and critical, not instinctive, and not innate, and not humanly universal. I mean, you might feel that some other characteristics are required for them fully to deserve the name scientific, but at any rate, that's a broad contrast between naive and scientific physics. And obviously the distinction isn't 100% precise, because, for example, scientific ways of thinking can become habitual. But it's plausible that we need some distinction along these general lines in order to understand thinking about physical matters. And of course, on reflection, we think that scientific physics can override naive physics. That there may be, for example, it may be that naive physics has something like an Aristotelian conception built into it, which is then shown to be wrong by further developments in physics. And so, at least when we're thinking reflectively, we can inhibit our reliance on naive physics and go with the scientific physics that we've learned. And of course, the process of internalizing a theory that is going to be more relevant to scientific physics than to naive physics, because scientific physics is more open to change under various kinds of pressure than something that may be, as it were, actually hardwired into us. But again, one can internalize ways of thinking which later become habitual. So, as it were, something that began as theoretical reflection, it could end up as something like an instinct, although it probably wouldn't be humanly universal and it wouldn't be innate. And so on the face of it, I think what we would expect is that there's a similar distinction for logic, that that on the one hand, we expect there to be naive logic, which is sort of pre-reflective ways of thinking on logical matters, which are instinctive, probably innate and universal to human beings. And on the other hand, there's scientific logic, which is reflective ways of thinking on logical matters, which are learnt and critical, not instinctive, not innate, and not humanly universal. So we'd expect there to be some contrast along those lines. And again, the distinction isn't 100% precise. And of course, scientific ways of thinking on logical matters can become habitual too. And it seems, in principle, on reflection, scientific logic can override naive logic in the sense that we might just learn that there are certain errors to which naive logic is susceptible, which then get corrected by scientific reflection on these matters. Whether there are, in fact, such cases is another matter. In the case of physics, it's pretty obvious that naive physics has to be corrected on various points by scientific physics, and it may be less obvious that in fact is needed in the case of logic. But it doesn't seem that there's any bar in principle to that happening in the case of logic as well. And again, the process of internalizing a theory is going to be more relevant to scientific logic than to naive logic. But one can internalize ways of thinking which later become habitual, and so as it were, the process of change in one's logical habits, as it were, it can happen even where originally what we had were ways of thinking on logical matters that would derive from reflection. So as it were, that's just, as it were, from the starting point of an anti-exceptionalist attitude to logic, one would expect some kind of rough analogy along the lines that I have explained. I mean, of course, we wouldn't expect that what goes on in the two cases exactly mirrors each other, but that there would be some rough analogy along these lines. Now, so I think that this is a point where that I left a gap for Q and A. So if anybody has just questions of clarification at this point, I know I haven't said very much yet. I'd be happy to take them, but leaving more substantive objections to the main question period at the end of the talk.
I think you can go on, Tim.
Okay, fine. Right. If that's clear enough, then I will. So now I want to say something about what I mean by internalizing a scientific theory. It certainly is meant to be more than, it's certainly more than just becoming familiar with it, and more than just coming to accept it for the sake of argument or something like that. So it's meant to be something like coming to believe it, to rely on it, to apply it, to act on it. I mean, it might be that just believing it is a perfectly good description of it, but you could also have some view on which, given the nature of scientific theories, that then they're not exactly the same as the objects of belief. They're not single propositions or something, and so what we need is not exactly belief, but some attitude fairly similar to it. And so one consequence of this, given how close I think the internalizing a theory is to be to belief, is that if one can't come to believe at will, one can't internalize a theory at will. So I think one of a whole lot of different things that I thought in the mix about the idea of taking on a new theory is some question about voluntarism, that it certainly is not the case that I could, for example, just become a dialetheist and accept certain contradictions or something, simply on the basis of a decision to do so, like as we're turning on a light. I mean, I am not capable of doing that, but that might not be for anything reason that's peculiar to logic at all. It could one possibility is that that's just an instance of the general phenomenon, that one can't simply, as it were, believe any old proposition or simply by deciding to do so. And so that's one thing that we need to bear in mind in these discussions, because it's not at all, as it were, peculiar to logic. Actually, I'm just going to have an aside on the question of believing at will, because I'm not, in fact, convinced that it's impossible to believe at will. So here's a kind of case that you might consider. So imagine the position of a member of the jury in a trial, and from early in a trial, there's strong evidence of guilt, and enough for belief by everyday standards, but not conclusive by legal standards. But it would seem it would be not at all unreasonable for somebody just reading about it in the newspaper to form a belief in the defendant's guilt. And so let's suppose that the member of the jury is strongly inclined to believe the accused guilty. Now, it seems to me that she might make herself hold off believing him guilty in order to hear the remaining evidence and arguments in an open-minded way. It seems that she could, in principle, do that. I mean, maybe she couldn't do it if the evidence was overwhelming enough, but in some cases, it seems, as it were, on the margin, she might be able to hold off believing the defendant guilty. But she might also, instead of that, decide not to bother doing that and just go ahead and believe him guilty. As it were, she might not be feeling so responsible that day. And so if she decides not to, as it were, bother holding off, but just go with what she's inclined to believe, then she will form the belief that he's guilty. So in a case like that, one might feel that the juror has in effect decided to believe that he's guilty. So I mean, I don't know what you think of that example, but it doesn't seem to me that it's plainly impossible or anything of the kind. And so I don't find it at all obvious that believing at will is in general absolutely impossible. But I think the kind of case that I've described is, as it were, a fairly marginal phenomenon that most believing or failing to believe is not like that at all, and we just don't have that kind of description. So as I say, I don't want to press this hard either way, but one might allow that in certain sort of marginal cases that believing at will is possible, and if it's possible, then I think one would expect that internalizing a theory at will is possible in the same sort of way. In particular, possible where the evidence is strong but not overwhelming. One might be able to hold off believing, because again, perhaps for quite similar reasons, that one wants to be open-minded in the evaluation of new data, or one might decide that it's not worth holding off and not bother to do it, and simply go ahead and form the belief. So I think if the kind of thing that I've described is possible in such examples of straightforward belief, it will also be possible in the case of internalizing a theory. But we shouldn't expect internalizing a theory to be in general like that. As it were, normally it will be an involuntary process. But to say that it's involuntary, I take it does not mean that it's not rational. That I take it that involuntary belief formation on the basis of overwhelming evidence is a perfectly rational process, even though it's involuntary. And again, one would expect exactly the same thing with internalizing a scientific or other theory. What does not seem a very promising model of internalizing a scientific theory is putting a sentence, or maybe a plurality of sentences, into one's belief box. It seems that there's more to scientific theories than that, and that it's going to be a significantly more complex process, which one shouldn't, as it were, picture in that kind of way. I think a much richer picture of what internalizing a scientific theory might involve is Kuhn's description of accepting a new paradigm in the structure of scientific revolutions, which is a much more elaborate matter than as we're writing something in your belief box. Now, of course, something that I must add immediately is that in saying that there's something to Kuhn's description of accepting a new paradigm, I'm not in any way endorsing any of the sort of horrible gestures towards relativism or constructivism or anything of that kind. So I'm taking Kuhn as more as a perceptive descriptor of scientific processes. I'm not endorsing at all the wackier parts of his philosophy of science. And one thing again that's worth saying about this is that although Kuhn is sometimes interpreted as describing scientific revolutions and the change of theory as some kind of collectively irrational process that just has to do with some sort of cultural power rather than anything to do with evidence. I don't think that's the best reading of the book. I think actually what he's doing is something rather more interesting, which is giving an account of how individual irrationality can serve collective rationality, so that the way in which both proponents of the old paradigm and proponents of the new one are, in some sense, irrationally obstinate and unwilling to change their adherence. Although as individuals that may make them irrational, they're actually contributing to the overall rationality of the process by making sure that the full explanatory resources of the old and new paradigm are properly explored. So, I mean, just to give an example, I mean, if you think about accepting something like Darwin's theory of evolution, it doesn't seem enough to put, as it were, the sentence in mentalese, species evolve by natural selection in one's belief box. It seems that as it were, something much more developed is required than that, and it's a lot more relevant whether someone is willing to accept specific explanations by natural selection. Of course, not just any old such explanations, but good ones. And as it were, someone with a general willingness to accept explanations by natural selection might well, in effect, have accepted the Darwin theory of evolution, if all the other details are right, even if there isn't, as it were, just a single formula or sentence or even a single representation, in some sense, that they put into their belief box or done something like that with. And equally, even if they did have the right sentence, as it were, represented in their belief box, whatever exactly that's the metaphor for, if in practice they were unwilling to accept any explanations by natural selection, one might well feel that they didn't really believe the theory. So I'm not offering a very precise account here, as you can see, of what it is to accept a theory, but the point is that it has to do with all sorts of patterns of thinking and belief, not simply with, as it were, just signing on to a particular proposition represented by, as it were, something like a sentence in the language of thought or anything of that kind. And it's certainly not the case that the person who accepts such a theory needs to have any kind of rule for which such explanations to accept. That seems, in fact, far too much to ask, because it would require one to have a fully functioning set of criteria for assessing individual explanations by natural selection, and I mean, you don't need to have anything as developed as that in order to accept the theory, and it's not even clear that that scientists who are expert in the area have something like a rule for which explanations by natural selection they will accept. Here's a kind of toy example, just so that we don't get too hung up on what the scientific details really are in such a case. So a particular theory of history which some people seem to accept is what's often called the conspiracy theory of history. And we might formulate it as a kind of generic claim that major historical events result from conspiracies. And I think it would be unfair to the people who accept such a theory to take it as a universal generalization, as it were, one which is true only if it's completely without exceptions. It seems like a generic generalization is closer to what's going on. And then, as it were, to get a foil to that, the competing theory is usually, well, at least in Britain, it's called the cock-up theory of history, that major historical events result from cock-ups, where cock-ups are just somebody messing up, some incompetence or misunderstanding or something of that kind, as it were, the usual foil to conspiracies. And as I said, of course, this is a slightly childish example, but it seems that what matters to internalization of these theories, that's whether you count as believing such a theory, and if we think of it in those terms, is one's disposition to explain events according to one pattern or the other. And it's clear that someone's disposition can change over time, and that you may thereby switch from accepting one theory to accepting the other. And I mean, there are all sorts of reasons why it might change. It might change in response to evidence, or it might change, as some byproduct of the aging process, or whatever it is. But these are certainly things that, in principle, can change. Somebody can go from believing the conspiracy theory of history to believing the cock-up theory of history, or vice versa. I mean, how many people do, in fact, make the switch is another matter. So I've put another break here in case anybody has questions of clarification. So I'll just stop for a moment in case somebody would like to ask about what I've been saying so far. I mean, I know I haven't actually said very much about the case of logic yet, but.
go on, Tim, I think.
Yeah, okay, I'll go on. That's fine. So I want to sort of, as it were, sidle up to the case of logic by discussing some examples which from mathematics, where we've also got somewhat similar forms of theory acceptance or theory internalization to the ones that I've been discussing. I mean, they might seem like almost the opposite of what should be going on in mathematics, but I think they're in fact closer than one might think to phenomena that are in fact quite widespread in mathematics. So, you know, it's well known that most working mathematicians are not especially interested in set theory and often don't know very much about it. So let's just consider a working mathematician who has encountered Russell's paradox as it were some kind of exotic curiosity. But this working mathematician doesn't know anything about formal theories of sets. I mean, he's, for example, has never been shown the axioms of Zermelo-Fraenkel theory with set theory with choice or something like that. And so he's just working naively with the normal set theoretic framework of mathematics, knowing that there are some problems for it, but also knowing that, as it were, it should be all right if you don't steer too close to the rocks. So, I mean, the kind of position such a mathematician is in, and as I say, I think this is in fact quite a common position for working mathematicians to be in, is that they have a defeasible disposition to accept instances of a naive comprehension principle for set existence, but while also being aware that it's not a universally valid rule. I mean, the way that this might work is that he just, as well, the default is to accept instances of naive comprehension, but when they look, as it were, a bit funny to him, then he won't accept them. So, I mean, so this is not a mathematician who's got some kind of rule to determine whether an instance looks funny, you know, any more than we have a rule book to check whether a given purported joke is funny. It's just that some instances do look funny, that he's got some capacity to tell where there might be trouble and then keep away from those. But where they don't look funny, he just goes ahead. And so such a mathematician is in effect treating naive comprehension as something more like a generic generalization, you know, something which holds for the most part. You know, it isn't the case that his dispositions have to correspond to a standard restricted comprehension principle. And it might even be quite difficult to say what that would be, because you know, if, for example, this is an applied mathematician who has to deal with sets of concrete individuals in applications of mathematics, that's something which standard versions of ZFC don't deal with, because they're only for dealing with pure sets. So that, as it were, there's a kind of gray area here, which working mathematicians managed to navigate quite successfully, but just on the basis of a bunch of dispositions, not on the basis of any strict rules. And now going closer to the case of logic, I think many people are in a similar position with respect to reasoning about truth and falsity. I mean, specifically reasoning with truth and falsity predicates. And so the analog of what I've been describing in the set theoretic case would be someone who's encountered liar paradoxes, but hasn't accepted any particular solution to them. So that they're aware that if you're incautious in the way that you use standard principles about truth and falsity, then you can get into trouble, and isn't aware of any consensus in favor of one way of handling rather than another. So it's simply that that they treat disquotational principles as generic generalizations, so they have a defeasible disposition to accept instances of these disquotational principles, but it's inhibited for, as it were, funny looking instances. And again, this doesn't have to involve any particular rule to determine whether an instance looks funny. It's just that sometimes it does look funny to you, and sometimes it, and in that case, you won't accept that instance of the generic generalization. But if it doesn't look funny to you, then you will accept it. And I think those kinds of disposition they're relevant even to first order reasoning in particularly in natural languages. I mean, reasoning in some formal language with a completely circumscribed vocabulary and so on is a slightly different matter. But let's consider just what would be formalized as first order reasoning, but it's being done in English or some other natural language. And one might think that as well, once we get to first order logic, then those kind of issues that I've been talking about just don't arise, because there aren't any paradoxes of first order logic as such. But it's actually a bit more complicated than that. So one example is disjunction introduction, where you go from a disjunct to the disjunction, from P to P or Q, or from Q to P or Q. But in fact, I take it that our disposition to accept instances of disjunction introduction it is defeasible, so that that you might well not accept the move, where although you accept P, but you regard Q as nonsensical or just funny looking, and in a case like that, you might quite reasonably be unwilling to infer P or Q from P, even though it's an instance of disjunction introduction, because you don't want to infer something that has a nonsensical sounding component, or a component that just looks funny, that, as it were, makes alarm bells start ringing. And so again, one doesn't have to have any rule to determine whether an instance looks funny. So even in these cases, just as it were, one of the least controversial rules of the propositional calculus, in a way, in our reasoning for in natural language, which has a vocabulary that is not circumscribed and sort of guaranteed safe in the way that for a formal language, for an interpreted formal language is supposed to be. In fact, we're working with something like these defeasible dispositions. And another example of this is actually universal instantiation, which of course plays a big role in Saul's arguments about the adoption problem. So one may be defeasibly disposed to accept instances of the move from everything is F to T is F, where T is some singular term. But you might still resist it when you regard T as suspect. And in fact, I think most of us would be reluctant to simply accept, having accepted everything is self-identical, but to go on to accept Satan is self-identical. And there may not be any very clear principle that we're adhering to in these cases, but this definitely looks like, as it were, a dodgy application of universal instantiation that a prudent person might reasonably resist, even without being able to give a very clear explanation of why. I mean, of course, you might just say, well, there's no such being as Satan, but you might not be sure whether that's even relevant to the argument or not. So it might not be clear to you as it were exactly what the problem is, but it does look like a problematic instance. Of course, I mean, one natural move to make at that point is to appeal to free logic, where the move requires an extra premise that roughly to the effect that T is something. But it's not clear that invoking free logic will solve the general problem, because one may need a defeasible disposition to accept instances of T is something. I mean, because if you're extremely as it were mean about what instances of T is something that you're willing to accept, you may render universal instantiation almost impotent, and so it's hard to get an effective way of thinking here without some kind of account, even if we're going with free logic, of when you accept instances of T is something, which in turn is not something that it's easy to give any general rule about. So, well, yes, as you see, I'm just giving a bunch of examples here to give a sense of what the phenomenon is like, and I think one thing I truly do agree with Saul about it is that it is very different if we're talking about reasoning in the wild. It's a very different thing from what one might get the impression of from just looking at cases in well-regimented formal languages. So here's another rather toy example. So we might have somebody who's learning arithmetic, and I'm using this now to talk about cases where we change dispositions, because I've mainly been talking just about the kinds of dispositions that seem to be involved. So we've got a learner who has a disposition to accept instances of n divided by n is equal to 1. And they've also got a disposition to accept instances of 0 divided by n is 0. And then, of course, predictably enough, they get into trouble when they put n equal to 0, because so we're going with the first disposition, they calculate that 0 divided by 0 is 1. And going with the second disposition, they calculate that it's divided by, that 0 divided by 0 is 0. And so, of course, that they come to the conclusion, if they're following that out, that 1 equals 0. And so in a case like that, what happens is that on reflection, the learner restricts both dispositions, so that in order not to allow the case of n equals 0. And from the point of view of somebody, as it were, just naively learning arithmetic, this problem might come like a bolt from the blue. I mean, of course, we're very well aware of it, and people may be, if in some schools, people may be warned straight off that you mustn't divide by 0. But somebody could actually learn a fair amount of arithmetic and acquire these generally quite good dispositions without having encountered this problem. And so there's something is going on with the dispositions here. I mean, so initially it might be that learner may retain both the original dispositions, but add a disposition to inhibit them for n equals 0. But as it were, they're still there pushing for their conclusion, but that's being blocked by a further disposition. And of course, later, I mean, all this can become completely habitual, and learner may just simply lose the original incorrect dispositions and replace them by correctly restricted dispositions. And that seems a genuine distinction, because it's positing a different sort of causal structure. But in any case, in an example, of course, a toy example like this, we've certainly got some kind of change in the learner's dispositions. Another kind of change is the following, that so we might have someone who's got considerable skill at arithmetical calculations, but without any disposition at all to reason by mathematical induction. I mean, I don't know, but maybe the ancient Egyptians were in a position like this, so that as well they can do all sorts of calculations and about addition and multiplication, etc. But they just, it's never occurred to them to reason by mathematical induction. And I mean, even when it's presented to them, it may not strike them as valid. That doesn't mean that it does strike them as invalid, but as it were, it may not simply be completely non-obvious to them what to make of this new principle. And of course, in order to understand the principle, you've got to have some sense of what a natural number is, but you might have that just from all the examples and from told that there's counting numbers and so on. It's certainly not the case that you need to understand a natural number by some kind of definition of which it's then just a relatively trivial corollary that that mathematical induction will hold. And of course, we could imagine, as it were, this rather docile pupil who accepts mathematical induction on their teacher's authority. And it's not that they can see anything wrong with it. It's just that they don't see why it should be valid. It doesn't, as it were, immediately strike them as compelling. And of course, since they accept it, the reasoning by mathematical induction may gradually become habitual for them, and they acquire a disposition for it. And so in that sense, they're as it were, they're internalizing mathematical induction. One might feel that this is not the brightest student in the class or something, but this is a perfectly possible process to go through. And I mean, mathematical induction does seem to have been a relatively late principle to emerge, despite its fundamental role in formal arithmetic. And now to talk about changing dispositions in logic. So as a result of some kind of reflection, someone may give up reasoning in accord with the law of excluded middle. I mean, of course, in my view, this would be mistaken reflection, because I think that the law of excluded middle is perfectly fine. But that doesn't mean that someone couldn't change their dispositions with respect to it, but just perhaps that they would be wrong to do so. And so if, for example, if someone has various sorts of background assumptions of a somewhat verificationist nature or constructivist nature about mathematics, then they might well get worried about the law of excluded middle and stop reasoning in accord with it, because it seems to them that it gets you into trouble in all sorts of cases, in particular in cases where we have no idea how to find out which disjunct of excluded middle is supposed to be the one that that holds. So again, as we're thinking how this process might go, it could be that this I take it mistaken logician, that to begin with, they consciously inhibit their disposition to rely on it. Suppose that they started out initially with just with a general disposition to rely on instances of excluded middle, and then as a result of this reflection, they inhibit those dispositions. But it would be quite natural that that later not relying on excluded middle becomes habitual, and they lose even the disposition to rely on it. That will take longer, but it's still can happen. I mean, that's typical with dispositions that as it were, first of all, we have to consciously inhibit them, and then after a while, we're just there's nothing there left to inhibit anymore. And so this person may end up disposed to reason according to any intuitionistically valid natural deduction rule, and not disposed to reason according to any stronger rules. Of course, I mean, various other changes to do with double negation and so on also going to have to happen for that. But let's assume that they do. And so in a case like that, it seems quite reasonable to say that this person has internalized intuitionistic logic. They've gone through a process of initially reflectively and inhibiting their dispositions, and then in the long run, as a result, actually modifying the dispositions, and that seems not at all unlike the case of someone acquiring a scientific theory. Although, of course, in my view, the theory that this particular reasoner has acquired is a misconceived theory, but nevertheless, it is possible to acquire it. So, of course, the description that I've given doesn't fully specify their dispositions to think logically, but I don't think we should expect it to. It's like the case of describing someone as having internalized Darwin's theory of evolution doesn't fully specify their dispositions to think biologically, but nevertheless, internalizing Darwin's theory of evolution is something that you can do. And I'm suggesting that internalizing intuitionistic logic is something else that you can do, although Darwin's theory of evolution is pretty good and intuitionistic logic is not so good. So just to be clear about what I'm counting here and what I'm not counting. So we can have, of course, a mathematical logician who's an expert on intuitionistic logic, but hasn't internalized it in that sense. I mean, they know all sorts of things about how intuitionistic logic works, all sorts of interesting methodological properties of it, and so on. But they haven't actually come to accept it in the sense of acquiring reasoning dispositions which accord with intuitionistic logic. And of course, one quite specific sign of this is that such a logician may use a classical metalogic in proving results about intuitionistic logic. Whereas I take it that someone who has internalized intuitionistic logic will use an intuitionistic metalogic in proving results about intuitionistic logic. And it's well known that there are, in fact, very significant differences between what you can prove in a classical metalogic and what you can prove in an intuitionistic metalogic about intuitionistic logic. And it's certainly an aspect of the way in which quite a lot of the literature on alternative logics is rather superficial, that that often no attention is paid to whether the proposed alternative logic is being used in the metalogical reasoning of its proponents, and so for example, proponents of fuzzy logic often for dealing with vague languages, they often use classical logic in reasoning about fuzzy logic, and that's in fact an extremely questionable thing to do. But as well, the fact that the literature on these matters is often superficial in that way doesn't mean that it's impossible for there really to be people who are alternative logicians in the full-blooded sense. So one phenomenon that's related to this, which is worth mentioning, is that someone who's familiar with a theory but may be able to simulate internalizing it. So in other words, they know how to think like someone who has internalized it. And this could be a theory in physics or a theory in logic. So a classical reasoner may know how to think like an intuitionistic reasoner, and vice versa. So that, as it were, each side may be very well aware of how the other is thinking, and for example, can predict what their response will be to certain moves in a debate between them, or whatever it happens to be. And I think those simulations are, they're worth mentioning in part because they may be used in deciding whether to change theories or logic. So that, as it were, if we currently assign on to a particular way of thinking about some area, and we can imagine what it would be like to think in the alternative way, then if we're finding the way of thinking about the area that one currently has as unsatisfactory in its treatment of certain problems, one can think through how those problems would be dealt with from the perspective of the alternative theory, but simply by imagining having internalized it, and then, as it were, reasoning under that imaginative supposition. And in some cases, as a result of doing that, one can learn that if one were to adopt the alternative theory, one would be in a position to give a much better account of cases. So in the case of intuitionism, for example, the relevant cases might be ones where we have no idea how to prove or refute some given mathematical conjecture. So the simulating internalizing can be a pathway towards deciding whether to really internalize or not. And again, we don't decide such cases by a general rule any more than physicists rank explanations by a general rule. Of course, physicists are able to give you some kind of explanation of why they prefer one theory to another in a given domain, but they will not be able to give you a tenable general theory of which explanations are better than which other explanations. So as we're not talking about deriving these judgments from any general rule. Now I left another gap for questions of clarification, but since we're actually not so far from the end, I think what I'll do is just go on to the final part of the talk, and then you can ask away when I've got through everything. So one issue that does need to be raised here is the one that, of course, Quine famously raised by talking about whether with these alternatives we're denying the doctrine or changing the subject. In other words, is it that we still mean the same by the logical connectives once we've changed our dispositions, and are just disagreeing about what to about how to reason with the connectives with the given meanings? Or is it that we've actually changed the meaning of the connectives in some way, and so that the apparent difference of logic may simply be a matter of the just as a superficial appearance, because the given symbols don't mean the same thing. And there are certainly cases in the literature on alternative logics where it seems very much as though there has been some change in the meaning of the connectives. I mean, for example, it might well be that a lot of the talk about quantum logics, it really has to do with some kind of change in the meaning of disjunction or something like that. So it's not, as it were, this isn't just a skeptical kind of doubt. This is a very pressing doubt. And since I've been talking about the case of the intuitionistic logic, just, I mean, for the sake of argument, I mean, the kind of question that might be raised there is whether we could interpret the intuitionistic reasoner, or the apparently intuitionistic reasoner, by applying something like, let's say, Gödel's translation of intuitionistic logic into classical S4, where it would turn out that, as it were, once we properly understood what this so-called intuitionistic reasoner intended by their connectives, then we would realize that there wasn't really any disagreement with classical logic at all. And I mean, it's surely the case that we can imagine examples where something like that, in fact, turns out to be correct. I mean, this intuitionistic reason might even tell us that this was correct. And it's certainly the case that an awful lot of work done on intuitionistic logic doesn't raise really any issues about which is the correct logic or something like that. But but I don't think that the case where it turns out that some non-homophonic translation into a classical logic gives the intended meaning. I don't think that that's at all the normal case. And it's certainly, as far as I can tell, when I encounter people who self-identify as intuitionists, and one does meet quite a few such people. Not everyone who works on intuitionistic logic is such a person, but maybe Heiting was such a person, and there are quite a few around today. I think they would vehemently deny in many cases that they could be correctly understood by anything remotely like the Gödel translation. And in particular, they may have no underlying language in which they reason in overtly classical ways, where the connectives that they're using when they're, as it were, in intuitionistic mode correspond to something more complex in this underlying language. And I think what's in fact a much more common phenomenon with self-identifying non-classical logicians is that they continue to use natural language logical constants, not and or, if, every, some, identical, etc., as words of the common language, in this case English, and that they interact with other speakers in appropriate ways, as many do, that in those cases that the most natural and most charitable interpretation is normally the homophonic one. I mean, if you've got somebody who's dissenting from you, let's say if you're a classical logician and they're a self-identifying non-classical logician who keeps telling you that you're making a mistake and is willing to explain to you why they think that you're making a mistake and so on in your reasoning. I mean, the idea that it's charitable to interpret them as somehow not really disagreeing with you, despite the fact that they keep saying that they are disagreeing with you, that seems a very perverse kind of application of charity. And what instead seems to be going on is that the self-identifying non-classical logician in such cases is drawing on the connectives socially determined meanings, and they're just disagreeing with other members of the speech community on what is the case as expressed by those connectives or about how to reason with them, so that as it were, these logical constants such as not and or, etc., they have meanings in English which are available for any competent speaker of English to use, and it can be clear from someone's behavior that is the right way to interpret them, i.e. homophonically, and so that the apparent disagreements should be taken at face value. And in a way, this is quite analogous to the kind of anti-descriptivist views of proper names and natural kind terms that we've learned to accept from Saul's work, where it's not the case that that as it were, two speakers who associate different descriptions with a given proper name or natural kind term, or who have different beliefs involving them, that they thereby mean something different. I mean, that they may simply disagree about the properties of the relevant individual or kind, and be drawing on the reference of the name, which is fixed in the public language, because they're using these terms as terms of the public language, not as it were terms of some peculiar idiolect of theirs, which is somehow independent of the way other people speak, although perhaps somewhat similar to it. And that kind of account, in fact, is perfectly available for logical constants as well as proper names and natural kind terms. I mean, they too are words of the public language, which we can use as such with their publicly available meaning. And when we do so, then it's not that somehow the apparent disagreements about logic can be explained away as a change of the subject. We really are speaking the same language without equivocation and disagreeing, just as we appear to be doing. So that's the kind of picture that I've been presenting. And on the kind of picture that I've been presenting, internalizing a new logic is a genuine phenomenon, and it's really just a special case of internalizing a new theory, that what's going on is not very different from what's going on when we internalize a new theory in physics or biology or some other domain. So thank you very much.
Thank you.
Thank
you.
you.
Thanks, Tim.
Thanks, Tim. Very provocative and interesting presentation. Well,
Talk
yeah.
closer.
Okay. Well, very provocative and interesting presentation.
Can you hear him?
Yes, I can. Yeah.
Okay.
Yes.
Do you want to ask something, or we'll let other people and then we ask, or what?
Yeah. Okay. I'll let other people first.
Oh, well, he wants to go to bathroom. So meanwhile,
Yeah.
If there are other questions, anyone wants to ask something?
Yes, Alan can go first, but otherwise, please just type the word question into the chat and you'll be added to the queue.
Okay.
Okay, have I unmuted myself?
Yes.
Yeah, okay. I like that. And so my question is actually, I'm not sure whether it's a question that's expressing agreement with you or not. It seems to be expressing disagreement. Near the beginning, you talked about how distinguished between accepting a theory, saying this is this statement of the theory, and you say you believe it, and internalizing it. And then you very quickly said that if accepting, coming to believe something isn't something you can do at will, then internalizing isn't either. Internalizing is a matter of, establishing habits of doing things. So you see a phenomenon and you start thinking, how would I explain that in terms of this theory? Or even before that, you look at it and say, okay, what features of this are salient in this theory? What are relevant to explaining it, and so on. But the thing is, the individual acts that you are forming the habit of doing are voluntary. So if I can give a totally non-logical example, Pascal thought that it would be a good thing for people to believe in God. Okay, its expectability is infinitely better. Objection, you can't just start believing voluntarily. And so his advice was, what you should do is start acting like a believer. Go to Mass on Sunday, say your prayers every night, et cetera, et cetera, et cetera. These are things would be come naturally if you believed and had internalized the belief. The belief would lead you, would guide you thinking, I should go to Mass today. I should say my prayers before I go to bed. But the individual actions are voluntary. And then he said, do this, and maybe you will come to believe. Okay, I think probably he thought the best analysis there was, and maybe God will give you the grace to come to believe. But as a psychology, as a piece of psychology, what you're doing is you are, the words of the end of your paper, you're simulating having internalized the belief. Maybe what an unkind observer would say is you are being a hypocrite, you are pretending to believe, but that psychologically this can lead you to believe, can be part of this, what leads you to believe. Okay, skipping over to the last part of the paper where you responded to my question in advance. You say our ability to simulate have internalized a theory is something that helps us to be seen between theories. And that's clearly right. You have to be able to look at what would be the consequences of that. Okay, what explanation would that theory lead to? You have to looking for the kinds of explanations that theory would guide, look for. What kinds of features are the important ones, which can be neglected. And the experience you have of doing this is what helps you decide for the theory. And can I give a specific logical example? Suppose you are interested, say, in intuitionistic mathematics. You don't believe it yet, but you start trying to understand it. Part of understanding it is to look at particular mathematical arguments and simulate being an intuitionist. So you look at, say, question, is the closed unit interval sequence compact? Okay, okay, that's it. Now the proof that it is goes, well, one of the two half intervals has to have infinitely many points in it. That's assuming excluded middle, better not do that. So as you do this, what you're doing is you are learning to inhibit the disposition to assume excluded middle in the way that an intuitionist would. You are simulating it, but the specific acts of thinking that you are doing are voluntary, and it's maybe I can imagine that the experience of doing this in many cases, you might at the end find that this is a more natural way of thinking. So it's doing what starts out as simulating, and you say that simulating can help us decide between theories, and looking at it maybe from a more psychological point of view, simulating it is a sort of, you are doing as much of voluntary about internalizing it. Okay, you're still maybe holding the thing as a hypothesis. You're hypothetically assuming the new theory, but then you say that it's a hypothetical, and then what you do for the next part of your thinking about the sequence compactness of the unit square is you act on the hypothesis. You do voluntarily the things that internalizing the theory would amount to, and that this may or may not lead to a sense of this is a natural way to think about it. Maybe we ignore the initial. So I'm not sure
Can I
whether
respond to that? Yeah. So, one point which I think is not so important, but in the Pascal case, it isn't actually necessary that you pretend to be believer. I mean, what the kind of self-manipulation that he's recommending might perfectly work if you were quite honest about your position, but just spent a lot of time hanging out with religious believers, and that still might cause you to end up believing. But I think that's not really going to the heart of what you were asking. So I think, of course, you're right that many of specific actions which you would take as could be part of what's involved in believing a given theory or whatever, or internalism, can also be done perfectly voluntarily. But I think if the kind of if there's something to the idea that on the whole belief is not something one can do at will, then there would still be test cases where you were not willing to go along with the pretense, and where there would be a difference in behavior. For example, if you were faced with someone that you somehow had reason to believe knew perfectly well whether God existed, and then they were going to reward you, for and then, I mean, they were offering you some bet on the existence of God or whatever, involving very high stakes. You, in a case like that, if you did the normal decision theoretic calculations, you would stop pretending to believe and just go with what your current belief state was. So as it were, not that I've got a huge stake in this, but I think for someone who thinks that belief in general is not something you can do at will, I think that they'll say that although you can do quite a lot in the way of simulating it without actually doing it, you can't. I mean, you can't go all the way. There will be, as it were, life or death things which will show that it was just a simulation.
Okay, thank you. It seems I would just say that in practice, psychologically, often it's all, even for the person who is doing it, it's hard to tell to what degree it's stimulation and to what degree.
Yeah,
but
I agree.
Thank you. And repeated, I enjoyed the paper.
Nathan Bice.
Yeah, so at the beginning, you stated anti-exceptionalism about logic, but I was getting a bit confused regarding what your response to Saul's argument actually is, because the examples you gave were examples in which I come to restrict what inferences I'm willing to make. But in Saul's primary example, it's an example of someone coming to adopt universal instantiation that currently isn't using it. And I take Saul's primary argument to be, well, you can't really come to adopt universal instantiation because the process of adopting universal instantiation would have to use that very rule. So there's no way of adopting it because you'd already need to be working with it. And I'm having trouble seeing your response to that particular argument, because if that's not true of, say, scientific theories, then we do seem to have a strong case for exceptionalism about logic.
Yeah. So of course, I mean, the case of somebody who doesn't have anything remotely like universal instantiation is pretty extreme. But the thing is, even in that case, of course, I mean, there's exactly the problem that Saul points out with just saying to yourself, right, from now on, I'm always going to apply universal instantiation or whatever. I mean,
right.
But that doesn't mean that there's no way of adopting it. I mean, if you, I mean, suppose that there was someone you admired who used universal instantiation freely, and you just started imitating them. And I mean, you can, as a result of your imitation of them, you might come to use universal instantiation freely, and that does not have to happen by, as it were, you giving you first of all arriving at generalizations about how they behave, and then instructing yourself with those generalizations. It could just be by imitation. Of course, that doesn't seem, as it stands, tremendously rational, but if you might admire them because the things seem to go better for them, and and that they find a better way of living than you had, and so part of your imitation of their better way of living might end up being by using universal instantiation. So that it seems to me that I mean, part of the point of what I was arguing was that one should be careful not to, as it were, over-intellectualize what has to be involved in these changes. I mean, of course, it's easy in the case of intuitionistic. I mean, in the case of classical logic, because it's a very strong logic, but most of the examples of alternative logics are ones which tend to be sort of weaker than it. But you could have someone who, I mean, again, I don't think this would be a good idea, but they could, they could adopt for example, the belief that there are at most 100 objects. I mean, which corresponds to and reason accordingly. I mean, there is such an extension of first order logic. It's pretty silly, and and if you start counting how many sentences are in or variables are involved or whatever, you can see there might be a problem. But I mean, it's certainly not part of my brief to argue that such deviations from classical logic are sensible ones. Just that it's possible to make them.
Okay.
Romina, follow up, but I'm going to limit you to 5 minutes so we get to the other questions.
Okay. I think that Saul would agree with a lot of what you said, and I would too. I mean, in terms of what you just said, I mean, I don't think the argument of adoption actually is, I mean, it's saying exactly what you just said, that we should not over-intellectualize the whole process, and it doesn't go against anything where you just pick it up because you are imitating someone and so on. I mean, the idea is that you cannot get it, you cannot develop this disposition to infer in accordance to UI from a statement of the principle or from someone giving it to you or you formulating it to yourself if you already didn't have it in your practice. And it might well be that you pick it up from people that you have around, that's not precluded by the argument. But I think that the whole idea was, well, look, I mean, as you said in one of the cases of math, well, maybe the teacher, maybe that person accepts the thing about 0 and dividing by 0 and so on the teacher's authority. Well, the point is that with UI, you couldn't accept it. Well, you could, even if you accept it on someone's authority, that would make you no good, because you won't be able to infer in accordance with it just by merely accepting it. And I mean, and I take it that even if in fact we internalize a lot of the scientific theories, the point would be that just by taking some central hypotheses and believing them, you could do things with them. You could take, I don't know, alternative geometries and treat them as a formal system and make deductions, right? But that would not be the case with something like UI. And that's what Sol singles out as what makes it special. And, you know, not like any other statement. Or I would put it this way, not just as a hypothesis, because of course then you can formulate the principle and evaluate it and so on. It's not just that. There has to be something in the practice already going on for you to formulate the system, to see what follows, and so on. And about the last part, about the part on intuitionism and so on, I mean, why do we have to read this change of subject, change of meaning, change of subject argument?
Change of logic, changes of
Yeah, that way. Because I mean, one possible position would be to say, well, yeah, there are different meanings and we can perfectly well understand what they mean, you know? And that doesn't, the fact that there's another meaning going on, there is another interpretation of the connectives, doesn't necessarily mean that we cannot make sense of it or that we can't communicate. And it seems to me that sometimes the intuition is going an extra step and say, well, and that meaning is incoherent, like damn it, let's say.
Yes.
But you don't need to go there.
Yeah, no, I agree. I mean, the fact that that we mean different things by the connectives, if it were a fact, would not mean that we couldn't communicate. And in fact, you know, if the difference in meaning is supposed to correspond to some non-homophonic quotes translation scheme like Gödel's, then that translation scheme would itself be, as it were, something that we could use to establish communication. So that that wasn't crucial to what I was saying. I mean, the point is just that if we mean different things by the connectives, then something that looks like a straightforward disagreement will not be a straightforward disagreement and may not be a disagreement at all. And so that was why I was discussing that case. I mean, in the case of universal, the main thing, well, first of all, I want to say that it's not that I have any particular desire to disagree with Sol. I mean, it's not, you know, so if it turns out that everything that he's saying in the adoption paper is compatible with everything that I'm saying in this talk, that is completely fine by me. And I certainly agree with him that a lot of the talk about just, as it were, jumping to some non-classical logic that one finds in the literature is extremely glib and superficial and is not really thought properly through at all. So I mean, I have no desire to defend all that kind of rather shallow talk. It's just, but I do want to defend the idea that logic is, like other areas, one in which we can disagree in our theories. And just on the case of universal instantiation, as I was suggesting, universal instantiation itself is to some extent a matter of one's dispositions to go with particular instances of it, because, you know, in a natural language where we don't have very much control over what sort of singular terms, for example, there are floating around, then probably hardly anyone will be happy just to endorse absolutely arbitrary instances of universal generalization. And the final thing I wanted to say about the kind of changes of disposition that I've been talking about, that, you know, I think reflection on the scientific cases suggests that these kinds of changes can, in fact, be perfectly rational. even though they may not fit a certain, as it were, slightly naive conception of what rationality would consist in. So although of course, some of the cases that I was describing may not feel very, very rational, but I think, as it were, on a proper understanding of what rationality requires, they may in fact be quite rational changes.
Daniel Boyd.
I wanted to ask if you would expand on some of the stuff that you were saying about internalizing like the Darwinian theory, and comparing that to the case of internalizing like intuitionistic logic. Maybe somebody that does that, maybe previously they had internalized some other logic. Part of what would be going on maybe is that previously they had some very general disposition to accept a sentence from its double negation. And if you internalize the new logic, that gets relaxed in some way. And that's not a matter of accepting something new or rejecting something that you previously accepted. It's more like changing a habit or disposition or something like that. And when you were talking about the biology case, the Darwinian case, you were saying something like it's not merely a matter of like adding sentences to your belief box. And this is the sort of thing I wanted to ask you to expand on. Why is it not like that? There's something that could happen where you change your view, or maybe you come to see the Darwinian theory as like a really powerful explanation, a better explanation to like maybe a theory you previously accepted. And then you accept some new framework. But what exactly is it about internalizing the Darwinian theory that is not simply a matter of like changing your beliefs? What are the maybe dispositions that aren't just straightforwardly understandable as like adding beliefs or taking beliefs away?
Well, so it's not that I'm so committed to saying that it doesn't involve a change of belief, but just that if we do think of it as a change of belief, it's very unlikely that we can understand it as something like, you know, writing a certain sentence in your belief box. And the problem is that you can, well, on the one hand, you can have the relevant dispositions to accept, you know, particular explanations by natural selection without having any one formula written into your belief box. And on the other hand, you might have that formula written into your belief box as were the generic sentence, and simply not do anything much about it, because after all, you know, a generic is doesn't really commit you to anything very much in particular, and so where the point was not so much to deny that it's a case of belief, as to say that if it does count as a case of belief, it's one that we have to understand not in terms of single internal representations or something like that, but by something much more like patterns of dispositions to, if, for example, accept certain types of explanation and so on. But if you want to say that, well, that's what believing the Darwin's theory amounts to, then I'm okay with that, as long as we've got the right picture of what it is that the belief amounts to.
That case is going to be different from the intuitionistic logic case, because in that case you're accepting like a new pattern of forming beliefs. And
in the case of intuitionistic logic, it's a lot easier to as it were be quite fairly specific about what types of inference are involved. But still, what we're talking about is dispositions to make inferences of certain kinds or to accept them, and so that you know, we've got, in both cases, we've got to be thinking about what kinds of reasoning dispositions the person has. But as in the case of the intuitionistic logic, as it were, we can be a little bit more localized in, you know, what particular forms of inference are going to be crucial.
Nathan Salmon.
Hi, Tim. Good to
Hi.
see you. Thanks for the talk. Can you hear me?
Yes.
Good. Let's see. So I have a question about, this concerns the nature of logic. I take logic to be a matter of correct reasoning. And there's no question that besides that, there's a theory about what is the correct way to reason, and that there could be disagreement, you know, among theorists about logic. So as you know, Hilary Putnam argued that, you know, Hilary Putnam changed his mind quite a bit, but at some point he argued that, you know, quantum mechanics and modern physics teaches us that classical logic is not correct, and that we should reason, we should give up the distribution law, for example. And one can imagine that, you know, his students at Harvard were sufficiently impressed by him that they thought that they should stop reasoning in accordance with the classical distribution law. And there's no doubt, I think, you're absolutely right, that students could internalize, in your sense, a different form of reasoning whereby they just forswear using or relying on the distribution law. Of course, it's difficult to do that, and sometimes you may not realize that you are actually falling back on the classical distribution law, and you think you're not doing so. But you can imagine a very, very clever undergraduate at Harvard who is very, very meticulous about this and just trains himself under Hilary Putnam's influence not to reason in accordance with classical distribution anymore, and really internalizes it in your sense. I mean, it becomes now second nature to this student. But I take it that the point of Saul's Lewis Carroll arguments are that that's a mistake. That's not the right way to adjust one's reasoning, that there's really a fundamental difference between laws of physics and physical theories and logic. And I don't mean theorizing about logic, I mean logic. There's really a fundamental difference between, you know, theories of physics and logic, and that the correct way to adjust one's reasoning, if one is going to do that, is not to ask the physicist or the scientist, you know, what have you discovered, or what new advances have been made that will impact the way I reason, but rather to consult one's own ability to reason and maybe be shown or be convinced that the way one has been reasoning was actually fallacious. So you don't do it by asking the scientist what the new advances are. It's really a fundamentally different way in which we go about doing this.
Well, I don't think I would make as close a connection as you're doing between logic and correct reasoning, because reasoning is a psychological process. And I don't think logic has anything directly to do with any psychological process. It seems to me that it's a bit like saying that what physics is about correct thinking about the physical world or something like that, which, I mean, that's just the bit about the thinking about the physical world that's a kind of distraction from what the actual topic is supposed to be, and that that in the case of, I mean, of course, some people are better reasoners than others, and in some way they're more in touch with I think, logical reality than the ones who aren't. But logic as a discipline is not concerned with the study of reasoning as a psychological process. And in the case of the role of experts, of course, I mean, we'd like to be able to think out everything for ourselves, but it may be, for example, that someone is disposed to reason from all from all exeges to some exeges without restriction, and it may be that that they don't, if an expert tries to explain to them what the problem is, they just get confused and don't really get what the issue is. But then they may, we'll just have to accept it on the say-so of the expert. They may realize that that's a sensible thing to do, because and I think when logical matters get more complex, as in higher order logic or modal logic or whatever, I don't think that there's, I mean, of course, what we're in effect then talking about is something that is extremely close to mathematics. And I mean, in the case of mathematics, the idea of deference to an expert is totally normal. I mean, we'll just take Andrew Wellesley's word for it, that Fermat's last theorem holds, or whatever it is. And the case of logic is actually not really different from that. But of course, what we tend to be talking about in these discussions are cases where the principles at issue are extremely elementary ones, and there it's more disturbing. But I don't think that the ultimate test isn't whether we can get someone to see that they're wrong or something like that. I mean, if it may be that they're thick. I mean, that they can't be brought to see that they're wrong, and that's their problem. So I'm not really sure what the disanalogy between logic and physics would be here.
Do I understand you correctly that you think that what's correct reasoning is a matter of psychology?
No, I said that reasoning is a matter of psychology.
Yeah, but I was talking about correct reasoning. I said logic is a matter of correct reasoning.
That focusing on the reasoning, as it were, as if what logic was doing was taking as inputs, roughly speaking, psychological processes of reasoning, and then delivering as outputs a verdict of correct or incorrect.
I wouldn't have thought that either. I mean, it takes in as input actual inferences. Now that, I don't think of that as psychological at all. And then it evaluates them, valid or invalid.
What do you mean?
That's closer to what it is.
Yes, but I mean, so that's, of course, that's one part of logic. I mean, that's metalogic in effect, because it's that's the classification of arguments. There's also as it were, a more first level of logic, which just has to do with learning various logical truths, and for example, that everything is self-identical, which is not metalogical. I mean,
learning that sounds very psychological to me, rather than what logic is.
No, the logical truth that you're learning is just that everything is self-identical. I mean, of course, the learning is psychological, but but it's equally psychological in when you learn some physics. I mean, the process of learning is psychological. But I mean, I think one thing to say that is that I mean, logic is not actually a unitary discipline at all. I mean, if you look at what logic covers, it covers what I've been calling, as it were, the just plain logic, which includes, you know, as it were, roughly speaking, the accumulation of logical truths. But there's meta logic, but I mean, meta logic includes both proof theory and model theory, which are radically different from each other, and then set theory, recursive function theory. So that, I mean, all of these things are branches of logic. So that it's in fact an extremely variegated discipline, as you know, as a look at a logic journal will show you. And I mean, of course, within that we can select certain areas that we find philosophically significant and demarcate them. But I think it's very unwise to make, as it were, these kind of generalizations about logic as a whole, because it just doesn't have that kind of unity.
But you do mean to be defending the view that Hilary Putnam had, that it makes sense to look to the physicist or any other scientist, I suppose, to instruct us as to the correct valid reason.
Well, I think the idea that we could discover from physics, I mean, no doubt with a whole lot of reflection on top of it, but that as it were, as a result of results in physics, that we could discover that that something that had been taken for a logical law was not in fact one. That it doesn't strike me that is, as it were, methodologically excluded. I mean, I think I don't have any expectation that will in fact happen. But I don't think that Putnam was making some, as it were, huge methodological error in supposing that in principle reflection on results in physics might give us reason to change our logic.
We disagree on that.
Tim, we are technically out of time, but if you're willing to answer the remaining questions, we can keep going.
Yeah, I'm happy to go on answering questions.
Okay, then Harold Teichman is next.
Questioning the analogy with physics. In physics, we have a pretty well-defined notion of what an experiment might be and how the theory might apply to predicting the results of experiments. And experiments are sharply distinguished from descriptions of experimental situations, perhaps coupled with how those situations might evolve. I mean, you have to actually do the experiment and let nature evolve. You can't just apply a formalism to the description and say, this formalism, you know, accounts for that description beautifully. So what would be an experiment in logic, and what would be letting logic run its course the way we let nature run its course in experiments?
So I think that the point of experiments is to produce, as it were, particular data points that we can test theories on. And I think one thing that is a bit different in the case of logic is that because of the extreme generality of logical principles, there's a tendency for as when purported logical principles fail, for them to fail absolutely disastrously, so that as it were, it's very easy to find data that are inconsistent with them without, as it were, actually having to produce them. So that, for example, if we get some purported logical principle that ends up entailing that there are at most two objects or something like that, then all we need to do is to find three objects to refute that, and we don't need to do any elaborate experiment for that. And similarly with principles in modal logic, which end up implying that whatever is possible is the case, then we just need particular examples of something which could be the case but isn't, and we know of many such examples in order to refute that. And so, as it were, it's in logic, it's a bit more like the case where, I mean, suppose that we had some physical theory, and then it turned out that it entailed that that motion was impossible, that everything had to be stay exactly where it was. Then we wouldn't need to do an experiment to refute that. I mean, it would just be refuted by, as it were, ordinary knowledge that we already possessed. And so in the case of logic, we typically don't need to do experiments, because the kinds of conditions that we're interested in are ones where lots of different data will give us all that we need. So that, I mean, that is that's a difference between logic and physics, but it's not a difference at the kind of very general level that I was talking about. And and I don't think that it's sort of excluded that experiments could somehow be relevant to logical principles, that as it were, where you actually wanted to do an experiment about throwing darts in relation to the axiom of choice or whatever it was. But I mean, that is not how logic has proceeded. But it's also the case, of course, in physics that not all of physics requires experiments.
Well, I'd say that experiments are decisive in physics, and the situation you're describing seems more analogous to me to pure mathematics. If one has a mathematical framework like set theory or category theory or something, and one wants to apply it to some specific area, one can, so to speak, perform the experiment of applying it to that specific area. But that application is strictly, as it were, in the intentional realm. There's no external causality that comes in to make a decision for you. And I think this is different in the case of physics. Well,
of course, physics is interested in causation, and causation is not a notion of pure logic. So causal matters are not of, as it were, special interest to logic.
Well, it seems to me that what counts as an experiment in logic is strictly at a linguistic level, so to speak. And what counts as an experiment in physics has to move to the extra linguistic level to be significant. And it seems to me this is roughly correlated with what some of the stuff that Nathan was just saying, but thank you very much.
Well, as I said, I was suggesting that in logic, on the whole, we don't need to do experiments because we have enough data for the kinds of questions that we're concerned with, even without doing the experiments.
Paul, are you still here?
Yes, I'm here. Can you hear me?
Yes.
Hi, Tim.
Hi.
Very interesting presentation. Thank you. This is really just trying to understand the view better and to see how it deals with the problem that Saul isolated. And it does go back to Nathan's question. So I take it that the real surprising punch of saying that logic is just like physics is that we have empirically driven rational revision in physics, and we want to say the same thing about logic. We want to make sense of that. Logic, and Quine's, of course, claim was that any logical principle earns its keep in exactly the same way as every other, and they're all at the end of the day empirically confirmed, empirically vindicated, and so on, could be empirically revised for that very reason. Now, the form, I think you addressed this, but I'm not entirely sure how to apply the stuff that you're doing with internalization to this way of thinking about revision. So I take the form, the clearest form of an empirical revision of logic is precisely the kind of thing that Putnam tried to give. So he said, look, this is something that you are treating as a law in your reasoning, the distributive principles. This runs you into problems. Okay, if you gave up that principle and adopted a different one instead, then you would have all kinds of benefits. Okay. Now, the thing about this is it really requires you to isolate what the law is that you are treating as a law in your reasoning. Really formulate the alternative law explicitly and have that show the rational benefits of, as it were, adopting this other law instead, and have that modify your practice in a rational way. Some of the remarks right now about logic and reasoning left me a little confused about what you think about this, but one of the important aspects of the discussion that seems to be common ground is that what matters at the end of the day is not what you believe to be a logical law, but what you treat as a logical law in your reasoning. So given that that picture requires you to be explicit about what law you're rejecting and what law you're adopting, how does your emphasis on internalizing a theory help with that?
Well, so in Putnam's case, of course, I think one thing that we're probably all, well, maybe there are some quantum logicians, but maybe we can all agree on is that that his specific proposal was a mistake, that it doesn't have the kind of payoff that he thought it had, and so on. But the point is, but what I'm insisting on is that we did have to look at the proposal and as it were work through to in particular see whether it did in any way help with understanding the quantum phenomena, which I think, as I understand it, it turned out it didn't. But so I don't see that there's any, as it were, sort of transcendental guarantee that there couldn't be some principle of logic that we normally rely on. I mean, principle, as it were, something that we treat as a principle of logic, which is in fact not fully correct, but that the exceptions to it can only arise for some strange reason in very special circumstances, perhaps experimentally produced circumstances, and so, as it were, and so what would be going on is that we we were getting these very hard to understand results from the experiments.
Right.
Certainly is the case and then somebody, as it were, came up with a different way of reasoning logically, such that if you adopted it, as well, somehow everything fell into place, and you could take you could understand the let's say the quantum mechanics as a relatively straightforward characterization of physical reality.
Right. Yeah.
And then, of course, they would have to get themselves into this alternative way of thinking in order to be able to explore its potentiality. But once they'd done that, I don't see any obstacle in principle to them, as it were, to them as showing us what it's like to think in that way, and then we could adopt that way of thinking, because once we'd adopted it, we find ourselves able to make much better sense of these puzzling phenomena, and then we might come to realize that in fact the thing that we'd taken for a logical law was not one after all, but it's just that it's very tricky to produce counterexamples to it. I mean, of course, I don't myself think that anything like that is remotely likely to happen, but I don't see that, as it were, the general considerations of methodology can just, as it were, exclude it without even having to look at what the specific proposal is.
Well, if I could say just a little bit more, I mean, there are two aspects here. One of them is that if we're only talking about taking what we took to be a law and then saying, look, we should restrict this in certain ways because it lands you into trouble in certain circumstances. So just use a sort of, as it were, restricted version of this law. That wouldn't be a full vindication of the Quinian picture, because the Quinian picture is very important to it, that you could jettison any law in principle and replace it with something else. So that's one point. The other point is that I guess what you're doing here is saying, as you did emphasize in the talk, but there's a question about exactly how much of the rationality of the move is reconstructed. Is you're split. Just suppose that there is this kind of array of pills that you could take, which would make you a UIer if you weren't already one. And what you're thinking is, well, suppose somebody gave me a reason for thinking I'm not yet a UIer, but there might be some benefits to doing that. I could take one of these UI pills, become a UIer, and see what it's like, and then make a decision on that basis. Okay. That's a slight parody, of course, of what you were suggesting, but it doesn't make any difference. The point is that the move there, the move to becoming a UI practitioner, isn't one that is a rational transition. It's something that you do irrationally in order to then explore the benefits. So the most you could get out of that is a certain kind of pragmatic argument for being a UI.
I think you could get an abductive from it. I mean, I think this is actually very similar to abductive reasoning. So that if you realize that if you started thinking in a certain way, that then everything would fall into place, and you would be able to understand a lot more than you can understand from your present position, and that might be the reason that motivate. I mean, of course, that would all be doing it just under a simulation, but that might motivate you to actually make the move. And I mean, I was brought up in philosophically in Oxford, where a very salient alternative to classical logic was intuitionistic logic. as advocated by Dummett, as a genuine alternative to classical logic. And although I've never had any sympathy to it as a real alternative to classical logic, I don't have a constructivist bone in my body. It was perfectly clear to me what it would be like to think as a constructivist and to adopt intuitionistic logic. And so that I don't think there's anything so mysterious about these cases where we have our current way of thinking, and then there's another way of thinking where we know how to think in that way, and the question is does it make sense to switch to this other way of thinking? Is this a better way of thinking than our current one? And we can explore that by, as it were, simulating internalizing the other way of thinking, which was something that I think, in my days in Oxford was something that people on either side of the classical intuitionistic boundary would do. And on that basis come to a decision about which way to go on broadly abductive criteria. So and I take it that abductive theory choice of the kind which is common in science is actually a perfectly rational way of proceeding.
Good, thank you.
Saul and Romina.
Well, okay, so, well, it's a very rich paper. You can dealt with a lot of things. I think probably people have said enough about why I think UI is an important case that could not be adopted. I don't know how much you're defending Quine's sense, but anyway, in Quine's sense, which was accepted by people as a hypothesis from which you deduce things. And you actually see in the literature of Quinean disciples, I don't know how much you're defending him. Actually, UI specifically cited as something that we use in scientific reasoning as part of, is another hypothesis and so on. And that, of course, is what I was opposing. But I think other people have said enough about that one. I do think, and don't think of this as psychologistic, that the original notion of logic was a normative theory of correct reasoning, though, of course, everything now found in logic journals, recursion theory, set theory, and so on, is not necessarily that, right? But I do endorse Nason's picture. I wanted to say something about the case of intuitionist logic, which has come up any number of times. My own semantics for this is inspired by the S4 interpretation, but otherwise one should read what the end, this is when I first came to understand intuitionistic logic. You can't just, I wouldn't have been able to just train myself, but I read, I think probably for the first time in Kleeni's book, what the intuitionists themselves say, and they give an interpretation, right? Which according to them is what's valid for mathematics. Now, one can understand this interpretation, and one could actually believe that on their interpretation, like, the basic thing is proofs, right? And an existential statement is given by a method for finding an instance, a universal statement, a method by finding a proof that would apply to each instance that it holds and so on, right? And negation, right? And so on. Now, they even sort of, in their interpretations, do occasionally use a classical connective, like when they say such and such has not been proved, not meaning that it's absurd, right, in the intuitionistic sense, but just that we don't have a proof of it now, right? So look, I don't myself think, I mean, Kreisel, for example, said there's also the negative aspect of intuitionistic mathematics, which is rejecting the classical ones, but one doesn't have to believe that in order to think one understands it and can do it, right? And well, I mean, even Dummett cites Kreisel himself as an example, right, of someone who thinks he understands both classical and intuitionistic mathematics and thinks they can both be right. And that is my own point of view, and that they give a different interpretation to the connectives.
And that seems different from the Putnam case.
And that's very different from the Putnam case, right? Yeah.
Where you don't really understand why you're supposed to give that up.
Yeah, other than just that one
it conflicts with
likes it. I mean, actually, if one really took the Putnam kind of picture, I mean, not logic, mathematics might be in considerable trouble. There's sort of a mythology, even that what justifies mathematics is that it works in physics, but actually physicists, I don't know enough about it to say a lot about it, but they use mathematically invalid reasoning all the time and seem to have a sense as to when it will be okay. Like, well, to take something that I myself might have heard of, like the Dirac delta function. So they just accepted it, whereas mathematicians had a lot of trouble figuring out how to justify it or whatever, right? So, but on this kind of picture, one would just say, oh, we should revise our mathematics. What that would mean is not very clear, right? Anyway, intuitionists, I think they give explanations. When I first heard of it, I thought, oh, what does this mean? But now when they give explanations of what they mean by the connectives, I do get it. And that's very different from the Putnam case. Or for the naive Dirac delta function case or whatever, right? Yeah.
I mean, the one problem with the idea that as well, there can be peaceful coexistence between intuitionistic logic and classical logic are the unique characterization results. So that, if we have a language in which there's an intuitionistic, supposedly an intuitionistic negation and a classical negation, and which can be applied to all the sentences of the language, then they will end up being equivalent to ethat other. And so either the intuitionistic one is behaving classically, or the classical one is behaving intuitionistically. So that there isn't really room for the two kinds of logic to coexist across a whole language, which is closed under both kinds of negation. So it looks as though that the most you can have is one or other of them will be holding for some
domain
fragment of the language or something like that. And so I mean, of course, I agree that we can make I mean, some sense of what they're saying about the about what their connectives mean. But then there is also the the claim that, as it were, that this is all that if we can't provide an explanation of the meaning of a connective in something like these terms, then it doesn't mean anything. And so that of course, it's true that the intuitionist program, I mean, as far as I know, they never came up with a promising proposal about how a negation that applied to empirical statements was supposed to work and interact with the mathematical negation and so on. And of course, and these are all reasons for doubting that that the intuitionistic program is going to work with its full philosophical ambitions. And of course, I mean that's fine by me that it should collapse. But I mean,
well, you were sort of reacting to Michael Dummett, who made intuition more of a very important option than it's regarded in the mathematical community. I don't know how many people really, most mathematicians have never even heard of it or don't know what's going on. Yeah, right.
Yes, no, I mean, I have no interest in pushing intuitionistic logic as something that ought to be studied more, or that philosophers should be treating as a serious option. I mean, but all that I'm, of course, it is in fact true these days that with sort of homotopy type theory and related developments, it is kind of has become a bigger thing in mathematics recently, but not in a way that I think would be a threat to the kind of argument that you're making. But my claim is not that that intuitionistic logic is, as it were, an option that we all ought to be spending a lot of time thinking about adopting. It's just that I don't think that we can dismiss it on kind of, as it were, general methodological grounds, as opposed to looking at how specifically that the program has played out, which I take to be not very well.
Tim, I think that the difference between you and so on, this is more on how you see it from a philosophical point of view, how you interpret what the intuitionists are doing. And I think that you consider it more like a genuine rival, even if it's not, than so that would say something like, well, there's another concept, and they're both fine. And it's not really a rival.
But I mean, I think that depends on which intuitionists we're talking about. And, I mean, it's, that many people
say, even if they don't.
No, I mean, obviously, like Hiding or whatever didn't think that, I suppose, right? But
Brouwer
clearly didn't, even though his best work was classical, right?
Yeah.
Right. It's a little weird in this case. Brouwer did think, I think, that he may have said stuff like that's homophonic, the classical mathematician means the same thing that I do, and they're wrong, right?
Yeah.
But certainly in the development of it, a sort of informal semantics in terms of proofs, right, and so on, was given for intuitionistic logic, and that, I mean, and I guess Brouwer has a role in the background. They always call it the BHK, Brouwer-Hiding, Kolmogorov interpretation, right? And
well, Gödel certainly thought there were two different concepts.
Yeah, Gödel thought there were two different concepts. I did, and Kreisel did, right? And so, right. Kreisel worked on intuitionistic logic a lot, with mathematics a lot, without accepting their view, what he called the negative aspect of intuitionistic mathematics. One doesn't have to think of it that way.
Well, I mean, it's clear that a lot of the work that's been done on it has been done in a spirit that was not setting itself up as a rival to classical logic. That's true, but I think that that doesn't mean that somebody can't push it as a rival, and some people have. And I think one point about Gödel and Kreisel's views about as well difference of concept and so on was that they were saying those things before the development of social externalist of views about how meaning is determined of the kind that you yourself are responsible for.
Yeah, I think it's like natural kind. Yeah.
And I think that once if one's willing to apply that as it were social conception of meaning to logical connectives, then you can get very different answers from the ones that I suspect and Kreisel were getting by thinking of these things in a much more individualistic way.
Yeah.
Okay.
Okay. Well,
Well,
thank you.
Thank you. We have made you talk way more than.
Yes.
No, it's great, and thanks so much for all the interesting questions.
Yes. I mean,
Thank you for
raised a lot of
coming.
issues.